Say you have an analytic function and you have a certain line integral. Can you then also show that for the calculation of this line integral, it doesn't really matter which path you take to go from the beginning point to the end point? So pause the video and see what theorem you can use to prove this. So let's see what we have here. So we have a certain starting point and a certain ending point. And then we need to show that it doesn't really matter whether we calculate our line integral like this over the line L1 or whether we calculate our line integral like that using the path L2. Now, what we can do in this case is we can try to join these two line segments into a single closed contour. So we can form, for example, a closed contour C by taking our line segment L2 like this. And then we can close the contour by traversing the line segment L1 in the opposite direction. So we need a minus sign here for L1. So what do we have now? We have a closed contour C. We have a function which is holomorphic inside this closed contour, which is analytic inside this closed contour, which means that we can go talk to our friend Cauchy and apply his theorem, which will tell us that the integral over that closed contour C of f of z dz will be equal to 0. And then we can just break up our integral in its two constituent parts. So for example, the integral over the contour C is just the integral over L2 rather, minus the integral over L1. And this thing should also be 0. Or to put it another way, the integral over the line segment L1 is indeed equal to the integral over the line segment L2. So it doesn't really matter which path you take, you always end up at the correct destination.